Hello class. Today we'll be looking at this new notation called sigma notation. Sigma notation is a shorthand on how we would end up writing a series out. So let's dive right into it, looking at this example problem here. Write the series in sigma notation. You should first note that we have this term, the first term being 1, the second term being 4 and 9, and at the last term being 100. So it's a finite series. That's the first bit. But the second bit is to note what is the relationship between all these terms. Take a moment to see if you can find some relationship between this first term, second term, third term, all the way up to figuring out what nth term this is. Alright, let's see what we can do here. So if we look at this series, we should note that basically I can rewrite this as 1 squared plus 2 squared plus 3 squared plus ... all the way up to 10 squared. In this case being that I can write a relationship saying that each term is going to be some value I squared. Could be n, could be any variable, doesn't really matter for this case. I just decided to use I. Well, in sigma notation, we want to use the letter sigma. This is a Greek letter, and we have two ways to define our terms here. I in this instance, so I'll focus on this is our index, and we have to define our index with a limit, saying that it can only go so far. So in this case we started off at some value. We'll say in this case it starts off at 1. So this is our limit of summation. We also want to say what's the end limit for this, which will in this case be our... So we're basically done here. We just want to define which each part is. So the variable here, the variable I, is our index, and any variable would have been our index here. And here, these are your limits of summation. And the function here, and I'm going to try and circle this bit, this is called your summand. Now we can use the sigma notation to actually abbreviate and use some formulas on the side here. If you actually note here, I'm just going to quickly explain that if you have the sigma notation saying that you have to start from 1 and you go to some count n of a and b also being incremented, you can take these separately and say the sums of these independent indexes will give you your total sum of this here. Similar to the other side, for number 2, you have C multiplying every A count, or every A term. So if you just pull this out, you can say that C is now being pulled out from every term, and you can multiply it back in later once you have your final sum. Now here, the sum of the integers, the bottom, so 3, 4, and 5, these are referring to different laws that we have if we have k here, k squared, or k cubed. Now this one should seem familiar, sum of integers, because we proved that in 13.3. So feel free to look at that. These other two, 13.7 is where they're proved. So you can feel free to take a look at that in your textbook to see how this one is done, or this one is done, but I'm writing these relationships out for you, for that is what the main topic I want you to take away from this part of the lesson. Alright, let's do one example and then we should be done. So for here, the following states that you should express this series here in sigma notation. So take a moment and make an attempt. First, I like to start off just simply by writing my sigma notation saying where I'm starting from. So I'll say, in this case, I'll assume I'm starting from 1, and then I'll figure out which term I'm going to. Well, in this case, if this is my first term, my second term, and there's 2 integers per, and we're going to 19 and 20, I'd say I'm probably going to have 10 terms. So we're going to have, say, 10 counts here. If you're struggling with this, I would simply look at these terms here and say that 2, well, 2 is going to be 2 times your first term, so I would have 2i. Well, then how do we get 1? Well, we just have 2i minus 1. Not so bad. We don't have to really think too hard for this. So let's simplify the system by saying that now sigma is equal to now 4i squared minus 2i. Now let's use our rules that we said before. In this case, I'm actually going to separate these to say that this is now sigma 10 I is your first term, your first count, 4i squared minus sigma 10i 2i. And we still have more to do. We can use other rules for the system, and I'm going to continue that over at the bottom left with, let me write an equal sign, with here, being that now I pull out the 4 for I squared, minus here, there's going to be 2 for I. Now we can do more plugging in. I'm going to use this for pink, do this term out over here, which is going to come out to n plus 1 multiply 2n plus 1 over 6, and this is multiplied by 4, and I'll have this one here minus 2 multiplied by n multiplied by n plus 1 over 2. Nearly forgot that. I'll plug in below 4. We're using our nth term, which is going to be 10 in this case. So 10, 11. In this case is going to be 20, 21 over 6 minus 2. And again 10, we're going to do 10 times 11 over 2. Plug that into your calculator. So you get 1540 minus 55 equaling 1485 as your total sum. Alright, that's it on sigma notation. I hope you enjoyed this lesson and look forward to seeing you in class.